Hello everyone, today I am going to talk about Arduino Uno. Arduino Uno is a hardware that you can program and make various projects based on it, such as making a remote control car, and you can also control a room temperature with the help of this Arduino board. So in this video I am going to talk about what are the elements that is soldered on this Arduino board and what is the working of it. So start from here. As you see, this is the push button. This button is used to reset this Arduino board. Suppose in the application time when your system get hanged and it stuck somewhere, then with the help of this reset button you can reset your system and your system will be work properly. And there is also a reset pin. Here is a reset pin, as you see. Let me focus on it. Here is a reset pin. This reset pin also reset this microcontroller when the system get hanged with the help of, if you input here a highest voltage, then it can reset the system. So this is the next element of this Arduino board, which is USB port. USB stands for Universal Serial Bus. It has a dual function. It supplies power to this Arduino board and it also helps to write a program on this Arduino board. With the help of this USB cable, you can connect this in here to this port, and this end should be connected with your PC or laptop. So the third element is the power jack. With the help of this jack, you can also provide power to this Arduino board. You have to remember that you should supply a DC voltage from between 7 to 12 volt here, so that your system will be not burn out. Other thing you have to remember that this terminal should be positive and other terminals should be negative. Now in the power section there is a V-in pin. From this V-in pin you can also provide power to this Arduino board, but you have to be careful here. You should provide a pure 5 volt pure DC voltage to it, and it should be regulated voltage, otherwise your microcontroller should be burn out. So be careful if you are willing to provide 5 volt power from this V-in pin. This is the BJT. BJT stands for bipolar junction transistor. It helps to reduce the current which comes from this USB port. And this is the comparator. Comparator helps to compare the two voltages and give output according to it. This is the voltage regulator. Voltage regulator helps to regulate the voltage which comes from this power jack. If you are going to provide a voltage between 7 to 12 volt DC voltage, then the output of this voltage regulator is always a 5 volt, because this microcontroller needs 5 volt input power. So whatever the voltage you are going to provide here, the voltage regulator will be always provide 5 volt to this microcontroller. So you have to always careful that you should always provide 7 to 12 volt DC voltage from this power jack. Otherwise your voltage regulator will be hit up more earlier and it will be burn out. So be careful here. Now as you see here, this is M7. M7 is a voltage regulator. It has a 2 terminal, cathode and anode. We can find cathode with the bar. In the cathode side there is a bar over this diode, and here this is L0RA. This is also a voltage regulator. It has 5 terminals and it regulates the voltage for this microcontroller. These two are the filter capacitor, which filter the DC voltage to get pure DC voltage. This is Atmega 16U2. This is a microcontroller which helps to write a program in this microcontroller through the SPI, and this is 16 MHz crystal oscillator which provide timing to this microcontroller. And these small white color elements are the capacitor, and these black color elements are the resistor. Here you see these black color elements are all resistor, and these white colors are a capacitor. Now the next important element is Atmega 328P. This is the microcontroller. It contains 32 KB of flash memory. In the flash memory you can write a program and save it, and there is a 1 KB of static RAM and 2 KB of EEPROM. These two memories are used for these pins. To save the states of these pins, these two memories are used. Now how you can control the pin of this microcontroller? As you see, there is a notch and here is a dark circle side by it, and from here you can count the pin that is on the that the microcontroller have. 1, 2, 3, 4, 5, 6, 7, 8 and so on. So this microcontroller contains 28 or 32 pins, but in this board there is a 28 pin. So there are important function of different pins that microcontroller have. This is a small crystal oscillator here which provide the timing to this microcontroller. Now this is the ICSP. ICSP stands for in-circuit serial programming. These pins are also used to write program on this microcontroller without using the bootloader. If you program the microcontroller with the help of this USB port, then there is a need of bootloader to write a program on it. But when you are using the ICSP pins, then there is no need of bootloader to write a program on it. Now I am going to explain the function of Atmega 328 pins. These are the power pins. There are 6 power pins here. First one is IO-REF. IO-REF stands for input output reference. This pin is used for reference voltage. And I have already told you about reset pin, and this is 3.3 volt. You can provide 3.3 volt voltage to other circuit from this pin, and here is a 5 volt. This is the output voltage which you take from this board. You can also provide 5 volt power to the other circuit or a sensor that you are going to connect to this microcontroller or this Arduino board. These two are a ground pin. Ground pin means these two are a negative terminal pin, and this is the VIN. I have already told about VIN. These are the analog input pin, as here written is analog in. So these are the analog input pin. There are 6 analog input pin from A0 to A5. So you can connect the analog sensor to this pin and provide input to this microcontroller. 0 to 13 are the digital pin. These pins can take or give the digital signals. Now 3, 5, 6, 9, 10 and 11 are the PWM pins. It has a dual function. It acts as a digital pin as well as it acts as a pulse width modulation pin. So what is the function of pulse width modulation pin? As we know that this microcontroller acts on the digital data. So if you take the analog input, there is an analog to digital converter in it. It will convert the analog data to the digital data, and the function of the PWM is it can act on these digital data and give output as a analog. And these analog pins, at these analog pins you can connect a servo motor or a stepper motor that need analog data. So from here you can take analog data. This microcontroller have a analog to digital converter. It can convert the analog data to the digital data, and the PWM will act on the digital data and give output to the servo motor or a stepper motor or other sensor or actuator that you have connected on this PWM pin, which required analog data. And here is a ground and A reference. A reference stands for analog reference. Now this is the on LED. When you are going to connect this Arduino board with the help of USB cable or provide power through the power jack, then this LED will be on. When this LED is on, then we know that Arduino have a power. Here this is also LED. It is connected to pin number 13 internally, and there is also LED, transfer LED and receive LED. These LEDs are blinking when you transfer some file from this Arduino Uno board to your PC or receive some data from your PC to this board. These LED will be blinking when you transfer or receive data from other hardware or other device. Now here you see www.arduino.cc. This is the official website of the Arduino, and it is made by Italy. So this is all about Arduino Uno board. So thank you for watching my videos. If you like my videos, then like it, share it, and comment down below. If you have any question, then please comment down below.